Okay, the next speaker is from NIF, Carla Manin. She's a software engineer for the SHOT data systems at the National Ignition Facility we heard about yesterday, and has been developing software applications for several projects for the past 6 years at Lawrence Livermore Labs. Over to you.
Good afternoon, everyone. Today I'm going to be talking about streamlining target fabrication requests at the National Ignition Facility. I would like to give you a bit of information about the NIF target fabrication. There is an estimated 500 targets produced each year. Targets are usually standard, but many need to be customized. Each target produced is usually paired with an experiment and a request. And requests go through a series of approvals before a target is fabricated. So in this picture here, or in this diagram, we can see that a target request comes after the schedule. The SHOT schedule has been defined. The target request goes through a workflow, and it goes from draft to closed when the target has been produced. So in this presentation, I'm going to talk about the software applications that the users have been using to manage these target requests. This is a screenshot of the former target request tool. This tool had a series of limitations. For example, the display of duplicate data. There were hard-coded features that prevented adapting to new engineering processes, and it had an overly complicated logic for sourcing data. So to talk about a little bit more about the limitations of this tool was developed in Oracle Application Express, and there were a few process and user interaction limitations, such as as I said before, engineering processes evolved, making the existing user interaction out of date. The underlying data architecture was not optimized for current use. Development over time led to inefficient use of data, and the page loading times of the application was very slow. As far as the technology limitations go, customization of the tool was possible only within the limitations of the APEX framework, and all development had to be done within the APEX web interface, which was very limiting. And also, unfortunately, there was no built-in version control. So we decided that it was time to develop a new application using newer technologies and on a new data model rather than modifying the existing application. Here we can see the new target request tool, or TRT for short. In this tool, we actually solved all those limitations that I mentioned earlier. We are now displaying common data. We have customizable features that are easy to adapt to the new engineering processes, and it has a simplified logic for sourcing data that speeds the page loading time. In this view, we can actually see the full view of the application, which is composed of 3 columns that are gradually displayed as the user makes his or her selections. And here's just a zoom-in view of the application. We can see that the action buttons are here at the top. These are the save, withdraw, and copy actions that are only needed at the end when the user has finished already building the target order. So here we see the target order, and then down below we see the short pairing data. So next I'm going to show you a sequence of steps to create a target request. When the user selects the Create Target Request button, the user will see this first column, and from here he will or she will have to select the flip ID. The flip ID is an identification name for the experiment in the facility. From here, step number 3, all the data related to that flip ID will be displayed in the first column, and from there the user has to go into the middle section to further select the other options for obtaining the target features. So in this case, the selected option was to copy from the target catalog. The target catalog has data from existing targets that are already in the system. This pop-up window displays, and the user has to further select other options. Then there are a few records displayed, and one of the records has to be selected in order to copy the features. Step number 5, we see all the features loaded here in the middle column. The user has the option to leave the features as they are here, or further customize any of these features in order to customize the target that is being built. And finally, step number 6, the user will have the option to save the TR once it's happy with all the information that is being loaded, and the TR number is generated. At this state, the TR is in draft state, which means that the TR can still be edited. And as far as the technologies that we chose to build this application, we decided to work with Node.js, Express, Kendo UI, JavaScript, jQuery, HTML, and CSS. Node.js, for those of you who don't know about this technology, is an open source technology. It is a JavaScript runtime environment for executing JavaScript code server-side. It is modern technology that is supported by a large community of developers, so there is a lot of resources online. And it is suitable for non-CPU intensive applications, and hence it is applicable to TRT. Express is also an open source technology. It is minimal and flexible Node.js web application framework, and it is written in JavaScript as well. It is the de facto standard framework that most of the Node.js applications use, so we decided to give it a try as well. Kendo UI is a commercial off-the-shelf library for data-rich web applications that provides more than 70 UI reusable components for the UI. And finally, we use commonly used web technologies that allow for an easy implementation for having Node as a backend. So the reasons for choosing these technologies, I'm going to begin with the front end, and we selected a model view controller pattern in order to complement all the technologies that I just mentioned. We selected this to provide a clear separation between the view and logic. It allowed to easily subdivide the UI in sections and panels, and this also allowed to subdivide the work between developers. It improved the performance dramatically because it allowed to ask the backend for data only when needed, and it simplified the addition of new panels and sections, given that the other sections didn't need to be edited or modified in order to allow for the addition of the new sections. And Kendo UI was selected because it provides a simple implementation, and it really helped to speed the development. It allowed to customize available UI components to the application needs, and it provided an easy integration with all the other technologies that we selected in the tool. It improved the look and feel. It made it look very simple and clean, as you saw, and we selected the other technologies, JavaScript, jQuery, and HTML, and CSS, to mainly complement the JavaScript backend. Here we can see an example of how we are using the model view controller and Kendo UI in a TRT panel. We can see here the middle column that we saw earlier. All the drop-downs are using Kendo UI in this section. And in this top section, when the user makes a selection, is driving the display of the menu options in the bottom panel. And this is handled by the controller. Then in this section, the drop-down, the list of values in the drop-down are obtained from the object model. Now to continue with the backend, we selected Node.js because it has proven to work well and be reliable for other applications that we've developed in the team. It allowed us to seamlessly connect to the existing Oracle database. It also provided a fast turnaround for developing the application, and it paired really well with other web technologies that we selected for the front end. We also selected Express because it's very easy to use and it's very well documented online. It provided multiple methods for querying the request and constructing the result as a JSON object. It also provided a thin layer of web fundamentals, of fundamental web application features without obscuring Node.js features. And finally, regarding the database, we use the Oracle database because it's the infrastructure used in the facility, and we also use it for other applications in the team. We selected non-Oracle database driver for managing the database connection because it's very fast and it's very stable. And we use Oracle library because it's creating a listening pool on the provided port, and it also provides a very easy way to handle the SQL queries. Now, just a note of caution is that the Oracle library is no longer being maintained, but is being added to the core Oracle database driver. And to finalize, for us, the use of modern technologies allowed the team to meet the overall project goals primarily within the development time. And now the tool provides faster loading time, an improved user interaction, and a smooth data integration. And given that we are using a model view controller, we see that the future maintenance will be simplified. Thank you.
Questions? We have some time. I had one question: did you have an ergonomics designer, or how did you address the issue of user friendliness? And did you have someone who was specialized in ergonomics to choose the colors and the sequences and so on?
Yeah, in the team we have a few developers who worked on developing user interfaces for a long time, and so we decided that the application was better developed if we went in sequence, so showing first the first column and then proceeding into showing the next series of columns in order to help the user go through the cycle of steps. Yeah.
Any other questions? Okay. Is there one there? No? Yes, there's a question there.
You mentioned that you use Flip ID in a TRT panel. Do you have any interconnection between Flip and TRT?
Could you repeat that question, please?
You mentioned that you have Flip ID in the TRT panel. Do you have interconnection between Flip and TRT?
Yeah, well, the Flip ID is coming from the database, so we're mainly identifying the experiment, pairing the experiment with a request through the Flip ID.
Okay, I think we must move on. No other questions, no? Okay, thanks again, thank you.